Hello, and thanks for joining us for another Molle Motorsports Piston Tech presentation. In this segment, we'll be continuing our discussion on piston to valve clearance. Previously, we've talked through some of the concepts and theory, and now we're going to show how some of the actual measurements are taken. To begin, we have a single cylinder mocked up in our short block with the cam installed. We have our cylinder head pre-assembled with some lightweight check springs, and we have the various tools and components necessary to complete the assembly. The first method we're going to show simply uses clay or modeling putty to measure the impression left by the valves in the piston. And we simply start by filling it into the pockets on our piston. It may take a little experimenting to find the right amount for the piston and cam that you have, and two, make sure you have a clean piston to start, because you want to make sure that the clay sticks to the piston or stays stuck to the piston. All right, with the clay in place, now we just complete our assembly. We'll start with the head gasket, the cylinder head. And we'll use a bolt or two just to snug it up. We're going to be putting the lifters into the bore, but be cognizant if you're running a hydraulic cam that even some of the lightweight check springs that we're using can actually compress the lifter, can compress a hydraulic lifter. So we're using some modified lifters that have been set up to be solid to take that variable out of our calculations. Next we'll put the push rods in and follow up with the rockers. We need to check to make sure both of our valves are closed and then adjust them for zero lash. Right. Now we're ready to turn the engine over through one complete cycle so that the valves will leave their marks in the clay. And now we just take it back apart and check our results. Okay. So looking at the results in the clay, we can see that the exhaust valve isn't quite centered up in the pocket, but we know that this piston is made to fit multiple cylinder heads that'll have different center lines, and we still have adequate radial clearance. On the intake side, we can see the center lines of the pocket and the valve match much closer, and we have plenty of radial clearance. To check the vertical clearance, we're going to take a razor blade and make a small cut in our clay. And then remove half of it. So we can see our vertical depth, and even to get a rough estimate, we can take some calipers and estimate clearance on the exhaust and the intake, and see that we're adequate. To show the second method, we're going to clean all the clay off the piston and then reassemble in the same procedure as we did to start. All right. We're going to fix a place to mount a dial indicator on the head, and then we'll center this on the retainer with the indicator in line with the valve. Just make sure that we don't have any binding. Good. I'm just going to roll the crank over to about 10 degrees after top dead center, and we'll zero the gauge. And then we'll see where the valve bottoms out on the piston. 100. We're about 132 there. Rotate the crank a little further. Re-zero the gauge. Same, about 132. One more time. Move the crank. Zero the gauge and measure. Now we're starting to increase. We've got 138 there, so we found our minimum point of about 132 thousandths on the intake. And then we'll move our indicator over to the exhaust. Alright, so we'll start the exhaust about 20 degrees before top dead center. Zero the gauge and check. About 190 thousandths. Right there, we're about 152. Move the crank, re-zero. That's about the same 152, which means we've probably found our minimum. So of the two methods we've looked at, you'll notice that the clay method gives you a good visual representation of where the center line of your valve is in relation to your pocket and gives you an estimate of radial clearance. With the dial indicator method, you can get a very accurate numerical value for your vertical clearance, but it doesn't tell you anything about your radial clearances. In summary, use the tools and methods that you have available and know the assumptions that you're having to make accordingly for each and figure those into your final calculations. Thanks for watching, and follow us on Facebook and YouTube for more informative videos.